hands-on activities later. And they will also be in the chat. So if you have any questions along the way, they will be there to help you on the technical part of our workshop today. So let us also get a quick hello from all of our facilitators. Can we hear from Mei?
Yeah, yes, hello everyone. Yeah, welcome everyone to this workshop. I'm Mei. Yep, over to
Thanks,
Jethro.
Mei. Hi, Jet.
Hey, good afternoon. Sorry about that. Good afternoon. Happy Saturday. I'm Jethro. Nice to meet you.
Thanks, Jet. Looking great. Next, can we have Jinwon?
Hey, everybody. My name is Jin. So nice to meet you all. Hope you all have a good time today.
Nice to meet you too. And next, can we have Wai Shin?
Hi everyone, I'm Wai Jin and nice to meet you all and hope to learn together.
Thanks, Wai Shin. Next, can we have Jessica?
Hello, good to meet all of you. Can't wait to start.
Thank you, and nice background. And next, can we have Maisie?
Yeah, hello everyone, Maisie here. Welcome.
Thank you. And Chin Xian?
Oh, hi everyone. Nice to meet you.
Nice meeting you too. All right, so these are the people that you should remember that you can always reach out to throughout our workshop today, and they will guide you on the hands-on activities and also setting up the environment, or if you just have any questions. All right. So now just a quick run through of our agenda today. We are here now at introduction to the event, hosts and speakers. And next we will have an introduction to Pandas and Jupyter environment. Actually, before that, I would pass the floor to our speaker of the day. And then we will have a refresher on Python and introduction to Pandas. We will have a short break. And then for the second half of the workshop today, we will put everyone into breakout rooms. So you guys have the chance to play around with the data yourself and get to experiment with some of the hands-on activities. And hopefully we get to wrap up by 4:30. So just a quick run through of our house rules today. First, we would really appreciate if you can mute your mic when the speaker is speaking in the main room, but please feel free to unmute yourself and speak out when you're in the breakout room and ask any questions. And yeah, along the workshop today, if you have any question, like I mentioned, just ask away in the chat and our facies will get to you immediately. And if you have any burning question, you can also raise your hand and we will unmute you. Next, so we do hope that you stay until the end of this session where we will share a feedback form so we could hear from you on what you think about this event so we can improve further in our future workshops. And last one, yeah, we will have a group photo at the end of this event, so make sure you stay until the end. All right. So the moment that we've been waiting for. It's our pleasure today to have Kian with us. Kian is a certified deep learning engineer with years of experience in coding using Python with a focus on data analytics using Pandas. So, and he will be our instructor of the day and will lead us through all the activities. And yeah, without further ado, I will pass the floor over to Kian.
All right. Hi, everyone. I'm Kian. Thanks, Briggs, for the introduction. Nice to meet all of you here. So actually, there is a participant, Olivia. He's raising his hand.
Sorry, no. I didn't mean to. Sorry. Let me just try to.
Okay, no worries.
Yeah, no worries. Right. So thanks for the introduction, Trix. I will so
you
we
want
are
to take
good
over
at
the
this
screen?
now, right?
Yeah.
Yeah, I can. Let me take over my screen.
Thanks, Kian.
Okay, hi. First of all, we just have just now Trix introduced about me, right? So I would also feel it's good to say what I do in my daily tasks. So as the introduction slide shows by Trix, I am a deep learning engineer, and in my line of work, I frequently use Python and also Pandas to do data analysis. And that's why today we have this small workshop whereby we will just introduce to all the participants on how to use Pandas to perform data analysis. So aware that some of us here are new to coding, and there are also some who are familiar with coding but in other programming language. But nonetheless, we designed this course, this workshop today in a way that everybody from different background, no matter you are just very new to coding or you are a seasoned programmer, you can also get something out from the session today. So we just hope you enjoy the sessions that we have today. And also, by the way, we are going to have 2 separate sessions, and this will be the first half of the workshop, and the second half will be happening next Saturday, right? So, introduction to data analysis using Pandas. So for those of you who have not heard about Pandas yet, what actually is Pandas? Right, so I'm just, let me adjust my screen. I'm just going to take this code from the official website of Pandas itself, where I could, Pandas is a fast, powerful, flexible, and easy to use open source data analysis and manipulation tool. And it is built on top of the Python programming language. Basically, it means that Pandas is a library under Python programming language. So for those of you who are very new to coding, a library just means that it is something extra, okay, that you have to configure into your environment, into your system before you can start using it. But configuring that library into your environment is a super fast process, as we are going to see soon. So Pandas, people mainly use Pandas to perform data analysis, especially it is good for structured and time series data. But we are going to see more about that later. So where actually is Pandas used, right? As mentioned, Pandas is built on top of Python, so it can be used for short scripting purpose to script some small programs. Like for example, today you have a data set, right? You want to do some analysis on it, but before that, we want to ensure that the data is in a very clean format, right? Like we want to remove all the missing data and so on. So by scripting, we mean that we can actually write a script using Pandas so that every time when we have a new data coming into our system, we can just execute a script and let Pandas do the programming work, do the cleaning work. So that's what we meant by scripting purpose. And then also Pandas is often used for data preprocessing. For example, today when we have a data set, right, we need to do a lot of preprocessing. Preprocessing means things like I want to clean my data, I want to remove the rows with missing values, and then I want to ensure that let's say if today I have a date of birth, all right, different people, when they want to enter the date of birth, right, they might enter it in different manner. For example, some might enter using day/month and then /year, and some might enter in another format. So all of this require data pre-processing so that we can prepare the data in a way that is feasible and easy for us to do data analysis. So data analysis is, I don't think I need to explain more about that. Basically, it's just we try to extract some insights out from data. And then also data visualization is about, after we extract the insights, when we try to present our insights, our findings, right? You know, people usually it's not that good at reading a long text of paragraph. For example, if let's say today, when we want to go and read a research paper or a journal or even a textbook, we find it hard, right? Because it's not that attractive, it is not that engaging. So using data visualization, we can present information in a chart or in a visual in a way that is attractive and can easily convey our message across. So that is what is meant by data visualization, and Pandas can also be used for that purpose. So on the left, you see a data science life cycle. So this is a general cycle of a data science project. And we see that there are 1, 2, 3, 4, there are 7 steps in it. And Pandas can be used Pandas is majorly used in these 2 steps, data preparation and exploratory data analysis, right? So now you know where Pandas is used. Then next, let us see when is Pandas suitable to be used. When we have, there are occasions where, you know, we have tools, right? Pandas is a tool, and not every tool is suitable for every kind of situation. For example, today I give you a hammer. You cannot use a hammer to do everything, right? Sometimes you need a spanner. Sometimes you need a plier. So when is Pandas a suitable tool to be used is when you have a structured or tabular data set. So what do we mean by a structured or tabular data set? It just means that the data set is in a table form or row and column form. So it is the most commonly seen data set among the data analysts and data scientists. So there are also some other formats, some other kinds of formats. So if you are in the field of data analysis, you also come across things like people want to do speech analysis. Some people want to do image analysis, video analysis. So for that kind of what we term as unstructured data set, it's totally different types of data set. For those types of data set, definitely we cannot use Pandas. So remember, Pandas is for when today you have a table, you have columns and rows of data, we can use that. And it is good when our data set is large. By large, we mean MBs to GBs of data. Maybe today you have 10,000 rows of data, you have even 50,000 rows of data. Then it is a good choice to use Pandas for data analysis. And then it is especially suitable for financial and time series data analysis, right? Why do we say so? That is because Pandas, at the end of the day, Pandas is a set of API. What we call API is simple instructions that we can use to instruct the program to actually carry out some specific functions that we want. And today, if let's say you're going to analyze financial data or time series data, some of the very commonly tasks that you want to achieve is maybe you want to get a rolling average of maybe past 7 days, right? So this type of calculation we can use Pandas to perform the computation in one line of code. So it will save a lot of trouble because there are already developers that have already done the hard work of coding out the scripts for you. All we have to do is just to call out the API to do the computation itself, right? So if you are still feel very fuzzy about the concept, later when we start going into the code, then you understand what do we mean by API. And if let's say there are also times when Pandas is not suitable to be used. For example, when you have a big data. So when we say big data, we are talking about terabytes of data. Maybe today, some of you might be working in large corporations. Maybe you are working in major telecommunication companies like maybe Maxis or Digi. So they have terabytes of data coming into their database because they have a large pool of users. So when you are dealing with those types of data, when you want to do data analysis on it, Pandas is not suitable. Why? Because Pandas is just leveraging on whatever RAM and computing resources that we have in our local computer, and it does not in any way enables distributed computing. So that's why when we have terabytes of data, right, when we want to do processing with Pandas, if the data cannot be fit into our computer's environment, our computer's memory, then it cannot be used. It is not suitable to be used. You just need to find another alternative tool for that. Maybe, for example, BigQuery, right? Google BigQuery. And as mentioned, Pandas is also not suitable for unstructured data. And when you require performance optimization, you can also search for other tools, right? So that is when Pandas is not suitable to be used. And let's move on. And after we knowing when we should use Pandas, right? The next natural question is who should use Pandas? If today you want to do data analysis, so you are a data analyst, and if let's say you are a data engineer, you want to do some data cleaning, right? Or if today you are a data scientist or machine learning engineer, you want to extract some insights from the data, you can use and you can consider to use Pandas as your tool, right? Because Pandas is, I would say, it doesn't have a lot of overhead. Like today, a lot of people in the industry, like data analysts, they often use Excel, right? So one problem with Excel is that when your machine the spec is not so good, you might find the data processing to take a lot of time, and it might be lag, and there are some issues of crash. And why that happens is because Excel is one of the program where we say it has a lot of overhead, right? Because it's very user friendly. But in order to have that user friendliness, we need to code in a lot of extra stuff on it, which makes it very resource intensive. So you can consider using Pandas if let's say you want a smoother data analysis process, right? And if you want to leverage Pandas as a tool to perform data analysis, you need to have both of this basic understanding of Python programming language. Why? Is because Pandas is built on top of Python, right? So today, if you don't know Python, you need to pick up some concepts of Python first before you can make use of Pandas effectively. And also, of course, if today you are doing data analysis, you need to have a basic understanding of the concepts. Right. So let's see how, after we talk about the 4W, right? You know why you want to use Pandas, when you want to use, where you want to use, and who should use. Now let's talk about how you can actually use Pandas. So for those of you who are not familiar with Python, so to use Pandas, we first need to configure Python. And Python is, you can install Python very easily. So let's say today, if you are using Windows, you can just go to Windows Store to install. All right. And if today you are using, I don't know, if you're using Linux OS, it comes natively with the OS, right? And after you having Python installed and configured into your machine, the next thing you need to do is to install Pandas. Because as I said in the beginning, it is an extra library. It doesn't ship natively with Python, right? So you need to install that. And also you will need a code editing application. So basically this is a place where it will make your work of writing code easier. So there are a lot of alternatives, like some people, they prefer to use VS Code, all right? And there are also there's this, if you might heard of it before. It's called Jupyter Notebook. It's also an environment where you can edit Python code. You can execute Python code, and then you can have the result display on your screen. So it is also a viable alternative. And also there are also some people prefer to just use a command prompt to actually execute the code. Why? Is because maybe they have the script already written down, so they just need to execute it in their terminal, right? So and then the next thing we need to but all of these tools we are not going to use today. Today we are going to use the cloud computing environment, where it's called Google Collab, to make things even easier for all of us. So let me just introduce to you what is Google Collab. So I believe you also received this link. So this link is basically a GitHub URL, whereby all the exercises, basically the scripts for today's workshop and next week's workshop is located in this GitHub repository. So you can just go into the respective directory to actually find it. So so just now I mentioned about Google Collab, right? So let's say today we actually have a total of 7 chapters of exercises of tutorial that is available for the workshop. So let's say today we're going to do this first, right? Intro. By the way, this we normally call it as a notebook file, Python notebook file. So if let's say you are in this URL already, in order to launch the Google Collab environment, you just have to click the link, right? I think I will open it in a new tab, right? So this is what we call a Google Collab environment, where it is a free computing environment provided by Google, and it comes equipped with some of the libraries that we need for this workshop. For example, Pandas is pre-installed in this environment, right? So it enables us to straight away. Basically, it helps us to manage our environment in a way that, you see, I don't need to do any installation. I don't need to even install Pandas. It is just readily available. So for example, this is the interface of the Google Collab, and there are 2 types of cells. This is what we call a markdown cell. So a markdown cell is like, you cannot execute code on it. It's just for reading and documentation purpose. You can edit it. So I think, yeah, you can click this pen and then you can edit. Saturday is good, right? And then there is this another cell called code cell, right? Code cell is whereby you can actually run and execute the code, whichever code that is on that cell. So let's say this line will print hello pandas. So today, if let's say you are on this cell, you want to execute, either you can click the run button, right? Run anyway. I trust Google, right? And this is the output. Or you can just click Shift Enter to execute the cell. So this is what we call code cell, whereby you can execute Python commands on it. One last thing I also would like to show you. So you might ask, this environment, right, is a cloud computing environment that is provided by Google. So today, if let's say I did something, or I want to upload some files into this Google Collab environment, how can I do so? So it's pretty easy. If today you go and search, I think you can search how to mount your Google Drive onto this Google Collab environment, right? You can actually find this as in the search result. So basically, I will just show you one very simple way, mounting Google Drive locally. So this is mounting your own Google Drive. So in order for you to do this, you need to have of course a Gmail account and a Google Drive. So you can just copy this code, right? And let's say today you want to mount your drive, your personal Google Drive onto this Collab environment. You need to add a new cell. Okay, tips are, if you want to add a new cell, you can click B. All right, shortcut key for adding a new cell, and then you paste the code and you just execute. Remember how to execute it? Shift Enter. All right, and then you take some time to run. And okay, apparently I have already mounted it. Right, so if you are doing it for the first time, it will ask you to do authentication. Right, some text here will appear out, and you need to copy and paste it in another tab. Then you need to basically authorize it and copy and paste back the link. So this is how you can mount your drive. And if let's say your drive is mounted like mine, you can go to, I think this one, no, the fourth icon here. You can go to the drive. So this my drive is your Google Drive, right? Okay, so that's how you can mount your drive, and from there on you can actually access your file. Okay, so by the way, of course, this is a optional thing. In order to complete today's exercise, you don't even need to mount your Google Drive also. It's just an extra knowledge for you. So let us start to go into the first chapter. I think the first chapter of the notebook is we're going to introduce about we'll just do a quick refresher on Python for those of you who are feeling very rusty with Python. And we are going to introduce about Pandas. What is Pandas? And what are the data structure in Pandas, right? So by the end of this notebook 1, you will know about all this. You get introduced about this Google Collab environment. You get refresher on Python. You know about what is the very important Pandas data structure, which is a series and data frame, right? So as I said, in order to use Pandas, you first need to import it because it's an external library. So to import a library in Python, right, you need to do this. Let me zoom in. Okay. Okay, so Pandas is the library name, right? Pandas. Right. This is a library. They have a very comprehensive API documentation. You can go also, and then there are also some guides on how you can actually do the guides on how you can actually leverage Pandas to do your day-to-day tasks. Okay. So in order to import library, you need to use this command, import Pandas, and this is an alias. So you can give it any alias, like today you want to call it what? Import Pandas as I love Saturday, right? Who doesn't love weekend? It's also okay, right? So you see there's no error here, means that the package is, the library is successfully imported in. And then you might wonder, okay, so let's see what will this happen. Yeah, so it tells us that this alias now, I love Saturday, is actually referring to the Pandas modules. Okay, so that's how you can import a library. But of course, that being said, the general convention of importing the library is using PD. That's what most of the people use, and I suggest you to stick with it also, because it just makes reading code. If today you want to share your code with your colleagues, it will make it easier. So imagine today you you share your code, right? Then your colleague see this, I love Saturday, he doesn't know what does it mean, right? So it's better sometimes to just stick with the convention, and I will do that. So let me, by the way, you can re-execute the code cell multiple times. If let's say you did changes on it. Okay, so that's how you can import a library. So now just to verify, Pandas is imported in this variable, alias name, right, PD. And then just a very brief introduction on Python data types, right? So, you know, if you are familiar with programming language, there are a lot of data types out there. In Python, there are a few basic ones, like we have an integer. So this is an integer without a decimal point, right? And also in Python, this is what we call a float. So I think in Java we call it a double, right? But in Python it's float, right? And this is a string, right? Basically, string is text in Python, right? Python doesn't have char, right? So for example, today if you give one character, right? And then, by the way, you can find out what is the data type of that particular data by using the type method, right? So for example, str means that it is a string, right? So this is a string data type. And after you understand that, right? Maybe I just very briefly talk about what this line actually is doing. So this is an assignment operation. If you want your machine to remember about this data, okay, you need a way to refer to that particular piece of data in your machine. So that's why we are assigning a into this, we call a variable, right? So every time you want to access this data a, you just have to call this char, right? This char variable. So this is what I call an assignment operation, right? So if you are working with Pandas Python, you need to know about this assignment operation. It's a fundamental basic of programming. And then for Pandas, we have two data structure that come along with Pandas. So today, if let's say you are going to use Pandas a lot, then you will probably spend most of or all of your time dealing with these two data sets, right? Series and DataFrame. So what is a series? Series is okay, I think let me do one thing. Should hide. Okay, you can also access these commands here. You can explore yourself. I think I want to clear all outputs, right? That'll be easier. So, okay, a series is, you can know a series as like today if you have a table, rows and columns. A series is the column that you have, right? So what do I mean by that? Let's execute this. So this is what I call a series, whereby it has it is just a column with a few rows of data, right? You can, I think that's the best way you can imagine it in that way, right? And what we have on the left here is the index. So as Python, as like most other programming languages, we start counting from 0, right? So this is actually this index 0 here means that this is the first row, second row, and the third row, right? So this is saying that the first row in this series, the value is 1, 2, and 3. And then the data type is, so remember just now we talked about integer. So this tells us that this series, all of the values is of data type integer, right? Then you might ask me how we can actually create a series in Pandas. So you just need to call the series method, right? So pd.series, and then in here, you just include the values that you want. So like I put 1, 2, and 3 as my arguments. And when I assign it to A to this variable A, and then I call A, I get this result. Right, this is how we can construct a series. And then also, this is also doing the same thing, right? But it's just, okay, maybe I want to explain about this. Range 3 is, this is just saying that I want to return a list of values from 0 to 2. Okay, so that's what that is happening. And then also, you can also put in other data type, not just integer. You can, just now we introduced about float, we introduced about string. You can also, like in here, I put in string, right? But one thing, okay, like in this series here, this column here, I have integer, and also I have a string data type. So anyone can guess what is this series data type going to be? Because each series only can consist of one data type, right? So you can type it in the chat. Okay, if I may review the answer is object, right? So object is basically, if let's say the Python or Pandas, they cannot determine what data type they should put in, right? They will put in object. So object is like an all-encompassing data type, right? So because as mentioned, one series, okay, can only consist of one type of data type. So this, because like Pandas is, you can tell it is quite confused because it doesn't know whether this is integer or string. So it just put the general type, which is object data type, right? And then, so you still remember this A is a series, right? And this series, they have attributes, and also they have methods where we can call them actually. So you can think of attributes as just the properties for that data type, okay, for that object. So let's say this A, remember this A is a series. If we call the data type of it, so it will output the data type of that series. So let us check whether it's it corresponds to the series itself or not. So let's go back to A. So as you can see here, this is A, right? We see that the data type is integer 64. So if we go back, you see the same thing also. Integer 64. So these are what we refer to as attributes. So today, after you have create a reference to that series itself, so remember A is the reference to that Pandas series, you can call the attributes. So there are also other attributes, like this is showing off the values. So 1, 2, and 3, and also you can get the index. So if you still remember, index is on the left side. Basically, index tells us where does the value locates in that series, right? So this is the index attribute. And we can also reassign almost all the things in a series. So today, like, okay, let's show B, right? So B, we have, this is our index. Remember, on the left side is the index, on the right side is the values. We can actually reassign the index. So how we can actually do a reassignment? We just have to declare call B and the index attribute, and then we assign the indices. So for example, I want to assign apple, banana, and coconut to this 0, 1, and 2, right? How do we actually do it? So by using remember this assigning operation, this is saying that I want to assign this list of new strings as to replace the existing index of the B series. Right, so let's execute this and see what will happen. Right, and then we can see that actually the index has been replaced. So if we show B again. Okay, you see that now B is different already. The index has been reassigned. And there are also other values like name and index.name, right? So I think for B, for this series B now, we don't have a name. Yeah, we don't have a name now. You can assign a name to it, right? So in order to assign it, you need to, of course, declare the appropriate attributes. So because we want to assign is the name, right? So declare it and then assign the string quantity of food, for example. And then we can even also give the index a name, for example, food index, right? And let's try to do it. So you see that B now has a name. The name is quantity of food, and the index also have a name, which is food index. And also we can do things like very simple indexing. So indexing is whereby we want to access the values. Okay, what this line means is that, okay, this is what we call a square parenthesis. When we're using square parenthesis, we are actually doing indexing in Python. And then we need to give an argument, which is the index that we want to index. Index that we want to get the value on. So for example, this is, I want to get the value of index 1 in B series, right? So let's check. If my code works, right? If today Python doesn't screw up, this line should return the value of 1. Why? Because banana is the first index. Remember, we count from 0 in Python. So apple is the 0 index, banana is the first index. Right? So let's see whether it shows 1 or not. Yep, indeed, it shows 1. And then also, since we already declared this index name as banana and apple and coconut, we can actually also using the index this what we call string now to actually access the value. So this should return. Anyone can type in the chart what this should return the value. Exactly. Yep. It will return 0, right? And also you can do multiple indexing. So this will return the values of apple and coconut, right? And then also there are some other useful method. For example, you can this also return the value of apple, and you can remove a row in the series also. For example, I want to remove banana, and you can also, this just says that we want to rename the series name, right? Okay. Okay, so you see it is renamed already. So these are some attributes and methods you can play around with using series, right? So just to just help all of you to recall, series is a column. Series is a column in a table, right? So how do we actually get a table in Pandas? So here is where another data structure comes in, which is DataFrame, right? So if series is a column, then DataFrame is the entire table itself, right? So let's say today, just to drill home that point, I'm going to create a DataFrame that is consists of a few series. So this is one series. Remember, series is a column. So this is just saying that I want to create a table with 1, 2, 3 columns. And in order to do that, we need to call the DataFrame method, right? And then we need to give basically this inside this parenthesis here, right, is the structure of the DataFrame that we want. So you see this E actually refers to the first column. Okay, remember this is the first series, then the second column, second series, and also the third column, third series. Right. So the end result of this DataFrame, right, supposed to be a table with 3 columns, which is what we have. So now you can see it starts to look like your CSV dataset or your Excel sheet already. This is a table already with 3 columns. And on the left, this is the index. So index A, index B, and index C. Right. You can actually specify the index here, right? And how, okay, maybe a little bit on how you can create a data frame. Right? There are many ways you can do so. This is one way. You can use these curly braces. So if you are familiar with Python, this is how we define a dictionary, right? And then this is the name or the key value. Basically, when you declare this, right, this is just saying that I want my column to be named using first column, right? You see the name is here, column name. And then this here is the values for that column, right? So the values, I want it to be a series with a value of 2, 1, and 2, right? So you see 1 and 2. And then second column is also the same. I want it to have a value of 1, 2, and 3. 1, 2, 3. And then lastly, the third column, I want it to be a series with the value of 0, 1, and 2. Remember, range 3 returns a value of 0 to 2, right? And then the index is A, B, and C. Then you might notice something peculiar here. What is NaN? So NaN is what we use in Pandas to represent a missing value. So it is an acronym for not a number. So when it's not a number, it's a missing value in Pandas, right? So why does it appear here is because this data frame, right, for the second column and the third column, I specified it to have 3 values, but the first column only have 2, 1 and 2. So that's why Pandas will insert NaN at the place whereby we did not specify any values, right? So this is how you can create a data frame. And of course, data frame being a data structure also, it has some other attributes. For example, we can access the index, we can access the columns. All right, so okay, maybe some of you, if you're not familiar with Collab, right, when you hover over the cell, you have a choice. Either you can click on the code or click on the text. So when you click on the text, right, it's just now this editing stuff. So you can put some text here for documentation purpose, right? You can also, if you click code, right, it will create a new code cell for you to execute your Python or Pandas command, right? So let's remove it. Okay. So remember just now we talked about how we can do indexing on series. The same thing we can do also on data frame. So this is saying that, okay. So this first column here is actually the column, right? So this is saying that I want to index the first column, right? So when we try to execute it, you will see it will return a. So remember this is a series, because remember data frame is just consists of. Okay, a table consists of multiple rows, multiple columns, right? So in that same analogy, a data frame is also consists of multiple series. So when we index this, when we try to index the first column, it will return to us a series, right? So just to validate my claim, if you try to do type, you return a series, right? And also you can create a new column. How you can do so? Let's say, for example, you want to create a new column called fourth column, right? And then you just have to assign a value for it. So this will create a new column, fourth column, with all of the rows filled with the value true, right? So let's just check it out. Okay, so you see there's a difference. The fourth column is created compared to here, compared to the original, right? And then lastly, also, you can also drop a column. For example, I want to remove the second column. Then you can use, remember you need to call the, okay, in order to call the method, right, or the attributes, right, you first need to declare the variable that you want to call on. So I want to call the drop method on the data frame. So you use DataFrame dot drop, and then you need to specify the column that you want to drop. So in my case, I want to draw a second column, and then actually you need to specify 1. This is to indicate that we want to tell Pandas that Pandas, we want you to search for the column, not the rows, right? So because a data frame, right, actually it has 2 types of index. One is the column index. So like you see first column, second column, third column, these are the column index. And then we also have row index, which is the A, B, and C. Right? You can access data in either way. So that's why if we don't specify axis, Pandas will get confused. So that's why this is telling Pandas that we want to get the second column in the data frame index. Right? So let's just try to drop that, and we see this. Right? Different. Okay, so I guess now is 2:58. I guess the time is just right. We have also created some practices for you to actually just practice on what you have learned just now, because in coding or in any other things you want to do in life, practicing is the best way to actually learn, right? So these are some of the instructions. You just have to, for each of the instructions, try to do it yourself. Okay, later we'll break into a breakout room basically, and then there are a few of the participants will be there, and also for each breakout room we will have a facilitator, right? You can, if let's say you have any questions, you can check with the facilitator on how to do certain stuff, but try to just accomplish all these exercises that we've given you. So for example, first we would like you to create a series with int64 data type, okay, and size of 5. So what does size of 5 mean? It just means that it needs to have 5 values, right? And then give it a unique name. So just now you saw how we can give a series a name using the name attribute. So you just need to create that. And next, this is almost similar, but the different data type. You need to create 64 data type, and using the size, create value size of 8, basically 8 values, give it a name. And the third is pretty similar. And 4, create a data frame object, right, with int64 data type in this following shape. Right, maybe one thing I want to explain is about shape, right? So let's say you see this data frame, right? Then the shape is just referring to the data frame, how many rows does it have, and how many columns does it have, right? So in this case, this data frame has 3 rows and 4 columns, 1, 2, 3, 4, right? So you can call the shape attribute to actually verify that, right? So you will see 3 and 4. 3 refers to the number of rows, 4 refers to the number of columns, and it is fixed in every data frame. So you don't need to worry about it might be different from data frame from data frame. So okay, how can I create a cell code, right? Just to confirm, right? So 3 rows and 4 columns. Okay, yep. So you need to create a data frame with that shape, and lastly, create a data frame using the series you created in 1 to 3. Right. So you can always refer to our provided samples on how you can actually do so. So yeah, I think we can break into breakout room now, and we will come back after 15 minutes.
Yep. So thanks, Kian. Yeah, everyone. So I am now gonna assign everyone to a breakout room. So just sit tight, and in a minute you will be teleported. So in each of the breakout room, there will be at least one facilitator that will guide you through the activities. I think we're actually on time, so I will give everyone 20 minutes for you to get familiarized. All right, see you there. Okay, then I'll pass the floor back to Kian to go through the solutions.
Okay, hi everyone. So I'm sharing my screen, right? Okay, and now let's us just very quickly go through the solutions because after this we are going to have a short break. So for the first instruction is to create a series with int64 data type and size of 5, right? So it's pretty simple. How you can actually do it is you just need to call the series method, right? And then let's say int64 means that, oh, by the way, a neat trick for you. Let's say you want to view the documentation of that particular method. In Google Colab, you can use Shift Tab. You hold it together, right? It doesn't come out. And Tab. Okay, wait.
Only works in Anaconda.
Okay, but if let's say you use control and space, right, it will give you a suggestions of the parameters you can use, right? So for example, this data type here, right, we want to specify that it to be int64, right? And then because we want the value to be int64, so we can just give it some arbitrary value, for example, 1, 3, 5, 4, 5, 6. So 5 values. And let's say if you want to give it a name, you can use the name parameter, and you can just give it a name here. For example, series 1, right? And don't forget to assign a variable name to it, right? So this is how you can create a series. So let's just call it, right, and execute it. Yep. So 8. All right. So that is series 1. And then for 2 and 3, it is almost similar. The syntax would be almost the same. So if I may just very quickly show you. So for the second one is create float 64 data type with size of 8, right? So okay, I just copy paste the code. So but here of course you need to give it instead of integer value. Okay, you don't even need to, maybe let's say you want to create 8 values, right? 1, 2, 3, 4, 5, 6, 7, 8, right? 8 values. You can just change the data type here. For example, I want float 64, right? So this will tell Pandas. It will tell Pandas that I want all these values here to be in float instead of integer. And then let's give it a name, maybe series 2. And this one, assign it to series 2 variable and execute. All right. So you will see Pandas will convert my values into float. And then this is the name. So the same goes with the last one is what I want to do. We want to create a series with size of 3 object data type, right? So let me create a series 3. So data type, let's say we specify to object, and the name we give it series 3, right? So object data type just means that, for example, you can include any string value lah. For example, I like, okay, and you just execute. So this is the third series, and the next exercise is to create a data frame with shape 5 rows. Remember, this is okay. This actually is the axis 0 and axis 1. So 5 means that we want a data frame with 5 rows and 2 columns. This is what this parenthesis here means. This bracket here means. And the data type is integer 64, right? So how we can actually do so? Very easy. So let's say we call the DataFrame method, right? And then we can use dictionary. Shape of. Okay, let's say the first column, we give it a first column name. So this is the, remember, after the curly braces, we need to specify what column name you want to give, right? So for example, here, this one, you want to give the name first column, and then we can use a series. Okay, you can just even use a list also, is okay. So let's say I need 5 values, like 1, 2, 3, 4, 5, right? And then you call, and then this is second column, right? Then the value maybe we give A, B, sorry, we just want integer, right? So 1, 2, 3, 4, 5, right? So this is done. This is the first column we already declared, and the second column we already declared along with the name and the value. So what left is just to execute. Okay, so you see this data frame has 5 rows and also 2 columns, and the shape would be same, 5, 5, and 2. And lastly is okay. Lastly, we want to use the 3 series that we have already created to actually convert them, not to convert them, but to make them into a data frame, right? So let's give it a name, data frame from series, right? And then let's call data frame. And we're going to use dictionary. So remember, we first need to give the dictionary item, we need to give it a name. So series 1. Okay, one very neat trick, you can just use the name by accessing the series 1 attribute, the name attribute. And then you just, the values is the series itself, right? And series 2, and then series 3, right? And you can just let us inspect it. Okay, so this is the data frame that is created from using the 3 series that we have defined just now. So by now you already can see that series is just a very easy way for you to visualize it is series is a column of a data frame, and data frame is just the table itself. And yep, so that concludes our first session, and I will pass the floor back to Chris.
Yep, thanks, Kian. So yeah, everyone, we are more than halfway through our workshop today. So maybe it's a good time for us to take a quick 5-minute break before we continue with the next part. So I will see you back here at 3:37.
Is Crystal?
Crystal, yeah.
Is Crystal still there? I think she is, right? Okay, changing the value of the data frame is. We are going to cover in. We are actually going to cover in the third notebook. So, but if you want to know it now, we can do a quick one. So let's say we're taking this data frame, right? So this is the original data frame with all these values. So if you want to change, for example, the first row, first column, right? This one here, if we want to change it to maybe 900. Okay, if you want to change that particular value, right? First, you need to know how to index. How can you actually get that value out first? So let's say if I want to get this one, I need to use the indexing method that I demonstrated just now to get that value. So how do you do index? Just use the square parenthesis and okay, you can use this method. It's easier. Okay, this ilog method. It means for index location, and then you just need to specify the index. So the value one, the index would be 0 and 0. Why? Because this 0 means that this is the first index of the row. Okay, this 0 here, and this 0 here means that this is the first index for the column. So this is this first column here, right? Then you can get the 1. Right, and after you get a 1, you manage to get the right value, you just have to do an assignment operation. So just now we want to change the value, right? Okay, and let us also just show the result. So this is saying that I want to assign the value 99999 into this index position. So you see that the value is changed when we call the same data frame again. Hope that answers your question, Crystal. And Brianna. So, okay, we are recording, right? Am I sharing my screen? I'm sharing my screen, right? Okay. So series and data frame, right? They are objects in Python. So if what do we actually mean by object is that if you are familiar with programming, object is just how do we refer to an object? We are using a pointer to refer to an object. So today, if let's say I have okay, let us see what is B. Okay, so today if B is has this value, right? If today I just assign another variable to B, for example, this is I assign B to a pointer to B, right? Or you can give whatever name, let's say hello bin form, okay, some name. If today you just assign, you do an assignment, right? They are still pointing to the same object, right? So meaning hello bomb, this variable, you have the same exact value as B. Why is it so? That is because they are referring to the same object, the same series in the computer memory itself. So what this means is that, let's say today I will reassign the value of B. Okay, I change it to Squid Game. Right. I cannot do that because I think it's integer. Right. So let's change it to this value. So okay, let us confirm that B has been changed. So we confirm that the value of B is changed. The apple from 0 changed to this value 99999. But the thing is that since hello bomb and B refers to the same object in the memory, right? Hello bomb, the value of the apple index will also be changed, even without we explicitly saying so. Why is it so? That is because they are referring to the same memory in the computer. So reassignment doesn't is not sufficient now. If let's say today you want to create a new object and you want basically you want them to have to refer to two different things. So you need to use the copy method if you want to create a new. Basically, you are creating a new copy from the previous object. So to just show that, right? If let's say we do a copy of we call the copy method. Okay. It just says that B, this copy of B, right? You points to another series in the memory. So okay, let us see. Copy of B now is 9999. Okay, if I change the value of B into 0, I change it back to 0. Okay, so B has been changed. And hello bomb, since it is pointing to the same memory as B, right? The value is also changed. But copy of B, the value is still as a 9999 because essentially we created a new copy out. So this helps us to mitigate. So sometimes you might find issues where you do a data analysis and then something happens, something weird when you're doing a reassignment. You see that the value is not what you have intended. So this could be one of the underlying reasons. So the tips is that if let's say you want to create a new copy, you just use the copy method. It's considered safer in that way, so that there is no unknown bug that will occur. Hope that answers your questions, Brian.
Thanks.
Okay, so I guess we can move on to the next notebook. So the second notebook is we're going to learn about how we can import and export data set, right? Because just now you learned about how to create a series and data frame, but in actual practice, no one actually, very rarely we need to create a new series of data frame by ourselves. Usually we will import an existing data set, right? And how we can actually do so. So by the end of this notebook, right, you learn how you can import data and how you can also export data. So always remember when you start a new environment, right? So now when you come to here, you click this link here, it will bring you to another environment. So you have to re-import the pandas module. Okay, so you just have to execute the cell. Okay, so we have imported the pandas module into this environment. Next, I'm going to show you how we can actually import data. So there are a lot of different file extension, right? For example, we have Excel, we have sorry, not Excel. Excel is in XLS, right? And then we have CSV file, and then we have JSON files, and there are also some very peculiar ones. Things like maybe you've seen H5 or some other files. Pandas actually provide a wide variety of this API to read different types of files. So according to the different file format, we need to use different method to actually read it in. So for example, if I want to read in a CSV file, I will just follow the link here. So this is a Titanic CSV file where I get from Kaggle. You can also access it if let's say from the data sets, right? It's actually in here. Okay, sorry. So okay, what I want to say is that we can read file by providing a URL, right? So this URL must be a valid URL which points to this data set. So this is a famous data set. If you have been to Kaggle, you know this is a the first introductory data set they used to teach about machine learning. And it is in a CSV format. How you can see, how you can check what file format does the file actually refers to, right? It's usually as at the file extension. So this is a CSV, right? So let's say you want to import this CSV file. You can call the read CSV method, and the first argument is either you put the URL to that data set, or if you have that file in your local machine, right? For example, I don't have a very good example, but let's say you have a file name Pokemon.csv in your local machine, right? You can also read it in. So basically, you need to supply the file path, right? And then, of course, you can also specify other parameters to achieve different things. So if you click Shift and just now I tried it works. I think it takes some time to load. Okay, I'm not sure why. Okay, but for every method, right, there are actually a lot of parameters that you can play with. If you result in different end result of the method. So this is a more simple one. We just specify the URL or the path, and then we assign it to a variable called CSV DataFrame, right? And then let's execute that. And then it will be loaded into this CSV DF as a data frame, right? And then this is just saying that I want to call the head or the first few rows of the dataset itself. So this is the data frame. We have actually loaded the CSV file into this data frame format. So we can see that passenger ID is a wife, P class name. Let's just cross check. All right. Wait. So you see that the column name are the same, right? And then the value also is the same, 103211. Okay, 103211. So this is how you can load a CSV file. And then basically you are creating a data frame from that CSV file. If that helps you to visualize it. And as mentioned, with different file formats, we need to use different API to actually call it. For example, I have this link, this dataset URL here. And so, okay, but this URL actually points to an Excel dataset, right? How am I sure that it is an Excel dataset? Is because this is the file extension is XLS, right? And then for that, we need to use the method read Excel. Okay, read Excel. And after that, we assign it to a variable Excel data frame, and then we just call the first few rows. Let's try to execute it. Okay, it's taking some time, but okay, I need to, let me clear the output. Okay, it's still running for some reason. Okay, but never mind. That is how you can read an Excel file. We can also read a JSON file by, basically it's pretty standard already. By now you already know that we just need to call the right method. So this is, since it is a JSON file, CT, this link has a JSON file, ct.json. We need to call use the JSON, read JSON method, right? And then these lines, we need to give it a true argument because this is, okay, if we don't put it, if we put this as false, right? If you say that, if you have some particular error. So that's why sometimes you need to also play around with other parameters to make sure that it is loaded correctly, right? So let's just check the whether it's correct or not. So this is a JSON file. So we can see that each this is what we call as this one row in a JSON file. So did it load successfully? Yeah, we said it's loaded successfully in the data frame, right? And that's how you can import a JSON file. And then after you import it, you can do whatever you want to do. Like you want to do some data cleaning, you want to check whether there are any missing data. Maybe you want to change some values in that data frame, right? After you do all this, if you don't export it into a new file, you just close this session. The changes actually doesn't happen. Why? Because you did not save the file. Just like today, if you are editing on Microsoft Word, you did editing already, but you didn't save, you just close it. Then all the memory will be wiped out. And basically your work is just gone wasted. So if you want to export, after you've done all the processing, you want to export your file, right? Just use this method. If it is CSV file, you just do on that data frame object, you call the toCSV method, right? And then you give it a name. So for example, this one, my file name is Titanic extracted.csv. And then this slash here is the directory name, or you can give it other name also, right? And then let's try to execute it. So you see it is successfully executed. If you go to your environment now, you will see a new directory, which is exports. And then you will see this Titanic extracted file here. Can I view it here? Okay, you can actually download it. Okay, you can try to download it, and then it will be the Titanic file that is extracted. And then this is pretty similar to how you read the data, different file format for the data. You need to use the corresponding API to the file format. So since this is an Excel file, okay, that's it. Sorry, if you want to export the data frame as an Excel file, you need to use the toExcel method, right? And then Excel, you know, Excel has a lot of tabs, right? You also need to specify what sheet name you want to use. So for this, I want to use the passengers index. So this index parameter is just saying that I don't want to keep the index in my exported Excel file. So remember, this is the index, right? 0, 1, 2, 3, 4. If you don't put it as false, this will also be reflected in the CSV file, right? So let's just try to export it. Okay, so you will see if you go to exports now, we have an Excel file format of the Titanic extracted file. And then lastly, JSON also you do the same thing. But instead you call the JSON to JSON method, right? And then I would say lastly, if today you are reading an Excel file, right, you need to be aware, like you need to make sure that you are calling the right sheet name, because like in an Excel sheet, there are a lot of tabs, different tabs. So if you don't specify the sheet name, Pandas will throw an error because it doesn't know which sheet name you are referring to. You want Pandas to load, right? So this is some intricacies. Okay, maybe I can show you. Okay, so you see this is successfully loaded. If let's say I don't specify the sheet name, I think you will throw an error. Oh, it doesn't. Okay. But maybe that is because I just have one sheet, right? If today you have more than one sheet, then you will throw an error. Yep. So that's why. Okay. So now we are going into our practice session. You just do two very simple things. First, in your environment just now, in your first notebook just now, in the intro part, try to export the data frame that you have created to your environment, and then you try to import the CSV file. Okay, you export the data frame as a CSV, and then you try to import the CSV into this environment.
Okay, so we have a shorter practice section for this notebook. So we will have about 10 minutes in the breakout rooms, and I will send everyone to your room now.
I think there's a question here from Amira Kenyang. How do we import data from a Google Sheet? Do we need to convert it to a CSV file?
Google Sheet. Okay. Okay, you try to do the exercise first. Let me explore, and I'll let you know the answer. Can we have the breakout room to be 5 minutes instead?
5 minutes. Okay.
We are behind schedule.
All right. So 5 minutes. See you in the breakout rooms. Okay, I think everyone is back.
Hi everyone, welcome back. Okay, let's just very quickly go through the questions. So for question 1, export the data frame, right? So you need to go to the first notebook. I think it's data frame. Right, this one, right? Data frame from series. You just need to do to CSV.
Kenya, are you sharing your screen?
Oh, so sorry.
I can't see it. No problem. Thank you.
Okay, now I'm sharing, right? So.
Yep.
Okay, just now we have 2 questions. Number 1 is export the data frame, and second is import it. So for the first question, obviously you need to go back to the first notebook, right? So the data frame that we want to export as a CSV file, so is this data frame from series, right? This data frame, we want to export it as a CSV file. So since you want to export it as a CSV file, the obvious choice is using the toCSV method, and then you need to give it a file name that you want to export. Let's say this small data frame, right? Let's just give it a name .csv. Then you just execute it. Okay, so this means that it is successfully executed. So let's try to check your directory in this Google Colab, and we see that this data frame .csv file is here, right? And this is a slight issue that we found of using this Google Colab, because if you realize the notebook 2 and notebook 1, they have a different environment. So you see they don't actually share the directory, right? So if let's say today you are doing it on your local computer, you can just for number 2, right, import the CSV file. So let's say you can just do pd dot using the read CSV. You just include the file name, right? If you are in your local environment, because your both notebooks will share the same directory. So a quick hack for this would be you download the data, right, from this environment, and then you can just, if let's say you really want to use Collab, and then you just upload it from your environment into here, and then you just read using the file. For example, if let's say I want to read a sample, let's say I uploaded it in here, for example, California housing test, right? So you can specify the directory, and then you just put in the name, right? And this will be it, right? You will be importing your dataset, right? So you can upload your files here. Okay. And to answer Amira's question just now on the Google Sheet, you need to go through some extra works if let's say you want to straight away import from your Google Sheet. I have found a Medium article here. I can share in the chat. But you need to set up some, you need to do some setup first. For example, you need to generate the API key, you need to do the authentication, and then you also need to install some other libraries for you to actually import directly from the Google Sheet itself. Another way, you can just download it as a CSV file and then you upload it. Right, let me just share the link in the chat. Okay, so I believe that concludes chapter 2, and let's go to the last chapter of today's session, which is chapter 3. Right, so you can go back to the GitHub repo and then you go to chapter 3. So basically we are going to learn about data manipulation, basically how we can index and slice the data in using Pandas. So as usual, we have to import the package, Pandas package. Okay, and then by now you should be already familiar with this method, which is just saying that I want to read a CSV file that is hosted on this URL, right? It's a CSV file, and we want to, and then we assign. Okay, we read the data set, and then we turn it into a data frame, and then we assign it to a variable called data frame. And then this dot head, right, is just saying that we want to print the first 5 rows of that data set itself. So let me just quickly clear the output. Okay. Okay, if you execute it, this will happen. Basically, we are using a data set of Pokemon. So you know Pokemon is a very famous animation in Japan, and they have these cute little animals, and they actually they bite one, they got attack, they can attack people one, and they also got defense. So these are some of the attributes columns for the Pokemon data set, right? So and then you can see this name. This is the name of the Pokemon. If you really don't know about Pokemon, you just imagine them as a special kind of animal from other planet, right? And how, okay, let's say today we have this data frame, right? We already loaded it as a data frame. How we can actually index them. So remember, I say that a data frame has 2 types of index. One is the row index, which is here, 0, 1, 2, 3, 4. And then we also have the column index, right? The column index is just the column name. And how data frame actually is indexed, right? Okay, when we call the columns attribute of the data frame, we are actually listing out all the index for the column. So you see name, type 1, type 2, total, all these other column index. And then we can also, if we just straight away call the index attribute, it will be the row index, which is from 0 up until the last, which is 800. So total we have this data frame, the shape is (800) rows and 13 columns, right? So we can assess the values that we want by using the index, the row index and also the column index, right? So let's say if we want to access the columns, okay, let's say we want to just check the name of the Pokemon. So this is what we call dot notation. I believe you're already quite familiar with it already by now. We use that to attribute to access the attribute of an object. In this case, you want to access the name attribute of the data frame. Why this works is because each series, right? So remember, series is a column. Each series is stored as an attribute in the data frame. So that's why we can access it this way. Right. So this returns the name, only the name column of the data frame. And then this is, you can actually see this is the series. And this here below, the syntax is slightly different. Instead of the dot notation, we are using the square parenthesis. This also, we are returning the name column, right? But remember, when we are using this square parenthesis way, right? This indexing way, the name, this name here, we need to close it and close it in double quotation mark because this is a string. It is not a variable, right? So okay, so we see that it returns the same result, right? What happens if I don't enclose it in double quote, right? It will throw me an error because name is not defined. This is saying that name is a variable, but actually it's not. The name is a series. Sorry, it's a string, right? So always remember to enclose it in double quote. So this is how we can get a column. And you can get multiple columns by just specifying it in a list, right? So this is saying that I want to return a data frame with name, HP, attack, and defense, right? So this is how you can select a data frame with multiple columns, name, HP, attack, and defense. So, okay, if we want to break it down, right? When I started to learning Pandas, sometimes I get confused on this, right? First you need to list down the attributes, right? How do you do that? You need to put all of them in a list. So this is what we call a list in Python. You put them in a list, right? The column name, we separate it by comma, and then we enclose it with a square parenthesis. And then after that, we need to do indexing because we want to get the columns. So this is, we want from that data frame, we do an indexing of the list of columns that we want, right? If I execute it, it will return the same result. So this is how, when we actually break it down, this is what is happening in the code. You can also further break it down, like let's say for example, just now, okay, we get the, okay, remember this is we getting the name series, right? And after we getting this, let's say you want the first index, first row only. You can further add a further indexing using this way. So this will return just solve the first row, right? So you can change it. Okay, so this is a column indexer. But I would say in Pandas, people usually will use this method, ilog and log. It stands for index-based selection and also label-based selection. So how you actually use this, right? So for ilog, you can only use integers, right? It only takes in index or integer values. So remember just now, when we have a shape like this, right? 8, 108. This means that we have 100 rows and 8 columns. Okay, so the same applies with ilog and log. The first value would be the row and the second value would be the column. So this is saying that I want to access the first column, right? When we just have a column here, it means that I want all of that columns. So this is, sorry, I did a mistake. This is 1 refers to the second row and all of the columns, right? So let's see what will return. So we see that this is the second row evident by the ID, And then did we return all the column? Yes, we see all the column is there. Name, until, generation, speed, attack, defense. Right. So if let's say, basically this is a shortcut lah. We don't need to, when we write just the column itself like this, right? It says that we want to return everything. And then also we can do this. So what does this tells us? So remember this is a column. Sorry, this is a row. So we want to return all the row, and -1 means that we want to return just the last column itself. Okay, so this is what is happening. We are just returning the last column, but we are returning all the rows. So this is the way of using ilog. Okay, and then for log, LOC, label-based selection, here is slightly different, where we can actually use string to specify what data that we want to index. So for example, this is, I want to get all the rows of the name column, right? So for this, if you try to use ilog for this command, right, you will throw in an error because you cannot use a string for ilog method. So you can only use log. So we see that, okay, all of these are the name columns of that data frame, right? And then if let's say we want to just select the second row, this is selecting the second row, and I want to return all the columns, right? You return this, you return the series, which consists of the results that we want, right? And then if let's say you want to select multiple columns, we can use log, and you want to return all the rows and only these specific columns. Remember, if you want to return multiple columns, we need to specify a list of, basically this is a list of column names. So let's try to execute it. So this will be written, right? And then lastly, okay, we know that now this data frame, the index is 0, 1, 2, 3, and so on, right? This index actually can be changed, right? So for example, if you want to set a new index, for example, maybe let you know why would you like to change the index sometimes is because we might want to search a data frame based on the name of the Pokemon itself, right? So if we don't change the index, we cannot do that. Because remember, now our row index is actually 0, 1, 2, 3. So if let's say I put Bulbasaur here as my row index, right, let's try it out. It will work. Why? Because my row index is 0, 1, 2, 3. It's not Bulbasaur. So if I want this command to work, I would first need to set the index first. So how you can set an index? You can use the set index method, and then this name here, you use the argument is the column name that you want to set. So here we want to use the name column. Drop, when you set the drop parameter to true, it means that we want to drop that column after you setting it as an index. So let's try it out. Okay, so you see that now this expression actually works. I want to return the row of this Pokemon name Charizard. And if you go back here, this here we also work now. Oh, it's not. Okay, because we need to use the new data frame, right? So you will encounter a lot of these issues whereby this bug will occur. Then you need to put on your thinking hat and debug to see what happened. So you need to call the correct data frame. So this is data with name index, right? So this is the data frame whereby the index now is changed to the Pokemon name. Okay, let's try to execute it. Still doesn't work. Okay, let's try this. Okay, and then okay, why it doesn't work just now is because just now, remember this data frame now, the name is removed, right? Because we dropped the name column. So in the list here, we cannot have the name column. So that's why. You can refer back to the recording if it happens too fast. And lastly, I would just like to show you how we can perform a conditional selection. What do we mean by conditional selection is that if let's say today we want to select only Pokemon with HP more than 200, right? So how you can do so, you can set this. Okay, remember this is we are returning the column. And then we set this condition, right? It needs to be more than 200. Okay, and then you can put this condition as an argument to the log method. Right, so if you try to execute this, okay, we see that, let's check the HP. We see that all the Pokemon here, the HP here is more than 200. Because this command here is telling us that we only want to return the data frame with HP more than 200. Okay, and if you understand this, this command here also will be straightforward to you, right? So if let's say we want to return only Pokemon with attack more than 100 and defense more than 100, you just specify the condition, okay? And then, but basically underlying it, it is returning a Boolean series, true or false. So by using that Boolean series, when we put it into the log method, it will return the result that we want. Okay, so if let's say we want to combine different conditions, right? After you specify the condition, you can use an AND operator, right? So this is just saying that I want a Pokemon with minimum attack condition fulfilled and minimum defense condition fulfilled. So let's try to execute this. And if you go and check the attack and defense of a Pokemon, right, all of them is more than 100. Okay, and this is how you can use the AND operator to specify multiple criteria. You can also use the OR operator. Okay, the OR operator is the pipe operator in your keyboard. Is beside your backspace. You need to use Shift to actually use that, right? So if I say this will return either one of the condition fulfilled. So either the attack is more than 100, as we see here, or the defense is more than 100. So you see here, this is the attack only 100 and the defense is only 60, but it is still returned in our result. It's because we are using the OR operator. It's saying that if the data frame fulfills either this first or second condition, just return it to us. So that's how. Okay, lastly, this is the last part, how to change values, right? So I believe these are already covered. Basically, this line is saying that we want to index this particular value in index row, index 1, row 1, and with the name, right? And then we assign the value Rilakuma to this, right? Okay, and lastly, if you want to change multiple values at once, right? So this is we are changing one single value. If you want to change multiple rows at one time, it will be very troublesome, right? Takkan you need to go through every row and set the values. So you can use the map method. So this is saying that for the HP column, I want to map every values in that column so that it will change to 0. Okay, so what this line is saying that I want to map every values of the HP to change it to value 0. Right, so this will also return the result, which is 0. And lastly, if you want to change every column you want to change the value of every column by the same time, you need to use the apply method, right? And then you also need to specify the axis. You are changing the column instead of the row. And then for example, we want to multiply the every value by 2. So you see here lambda x, right? This is just means that you can imagine x is referring to that is a variable for that value, okay? And for that variable, for each and every variable of that value, we want to multiply by 2. So let's see when we try to execute that, what will happen. So we see that the index here just now was 1, 2, 3, now become 2, 4, 6 because we multiply it by 2. And then the name, right, you see here is also just now was Irisol, but here you see it's like a duplication, right? That is because when we multiply a string in Python, it will just add a copy of itself. And then you see this, all of the values are multiplied by 2 using this applied command. So this is the thing that you can actually practice on, right? And always remember one thing is that this method, right, if you don't assign the value, just like if you edit Microsoft Word, you don't save it, the changes will not actually be saved. So, okay, to demonstrate that. So you see this data frame here is every value is times multiplied by 2 already, but when I call back the original data frame, it's still the same, right? HP is still 45 compared to this. So remember, if let's say the operation, if you want to save the operation, you can assign it back to that data frame, doing an assignment operation, right? Okay. And if you try to check it, the data frame now, you see it is the changes is applied, right? And lastly, we have this practice section. So these are some work that, so the next week, you try to do this at home, we practice it, and next week when we come back, we're going to discuss the solutions together, right? So this is just saying that some instructions that you have to do on your own, like subset the following columns. So get a data frame in the same Pokemon dataset data frame, and you just try to extract out these columns on special attack, special defense, and speed, and assign them to another variable. And then the second one is you locate this particular Pokemon and you, along with these attributes, special attack, special defense. So for example, you get something like this. Piglet is a Pokemon, and then the special attack is 35, 10, and 70 for attack, defense, and speed, right? And then the third one is use the log and ilog method that we introduced, okay, and just assign this index 50, row 100, and row 150 to another data frame. Try to subset. And then 4 is you try to go into a data frame and modify the value of attack and defense of this Pokemon knowledge. And 5, you create a subset of original data frame, okay, by only using the first generation Pokemon. So this tips for you is look for the generation column and do a conditional selection. Okay, you can refer to the code. And 6 and 7 pretty much is just deals with conditional selection. All right, the conditions is here, you need to fulfill it. All right, so these are practices for you to bring home to practice. Always remember, practice makes perfect. When you practice more, the concepts will really help you to learn about Pandas. So I guess that marks the I guess that marks my presentation for this third notebook. I'll pass the time back to Trix.
All right, thank you so much, Kian. I'm mindful that we're a bit behind time, but we do have a question from Brianna in the chat. Can I use ilog to display multiple columns, or it will only work for log?
Okay, Brianna, to answer your question, ilog and log, the functionality is almost similar. The difference is that in ilog, you cannot use string. So like just now, if let's say you want to display the row for Charmander, right? Using ilog, it will be a bit difficult lah, since you need to know the row index. So in short, ilog is just you can only use integer, but for log you can use string to do the indexing. But both of them can return multiple columns and multiple rows, no problem.
Okay. Did that answer your question, Brianna? Okay, yeah, she said okay. All right, so that's a wrap for all the learning that we have for today in part 1. I'm sure all of you know we will continue with part 2 same time next Saturday. But everyone, please do not leave yet. If I may ask everyone to, if you're comfortable, to turn on your camera for a group photo.